Yeah, yeah, go ahead. You can join anyone which you feel is better. You can join anyone which you feel is better. Yeah, yeah, so the both the links are of TA session only. Okay, so you will have to choose which one to attend. Right? Yeah, right. So the thing is, if well, see, we TAs do not interact with each other. Okay, so I don't know what they are teaching. They don't know what I am teaching. But yeah, more or less the things are going to be the same. The material won't be significantly different. Okay, any more questions? Any other question regarding logistics? So I hope my screen and everything is visible. So at least my video is visible and audio is clear. If at any point you feel that my screen is not visible or something like that, you could just tell me. Okay, so I think I will also have to join through my iPad so that the iPad screen is visible. Okay, so I have started the recording. I'll switch to iPad. Just a second. So, so is the screen visible? Can someone just confirm? Okay, just give me some 1 minute. Just want to see if everything is fine or not. Just a second, yeah. So it looks like my OBS is not working properly or something. Okay. Uh, I don't know how to correct this, but okay. So okay, there might be some issue in the recording. Like the screen might be a little bit smaller, but I think it should be fine. There shouldn't be any major issues. So anyway, I will just get started. Uh, anyway. So if at any point you feel like you want to ask some question or my screen is not visible or something is not correct, you can just unmute yourself and just speak, okay? Uh, don't hesitate. You can just speak out. So, okay, so this was lecture one. So today I will be solving problems of week two. Some problems which are related to week two, not exactly week two problems, which might be helpful for you in understanding these concepts. Okay, someone is joining. So, right, so week two was more about uh, conditional probability. Uh, Conditional probability. There were some problems, uh, and then there was random variables, and lastly, CDFs, right? Cumulative distribution functions. So, today we will just solve some problems on these topics, right? I hope this is fine. Uh, Let me start with some basic problems. So let's take this first problem, okay? So the first problem is as follows. There are three, okay, so let's say there is a college and there are three subjects, maths, physics, and chemistry, okay? And the probability, so there is some grade, okay? So let's say that grade is EX grade, okay? So the probability of uh, the probability of getting an EX grade in maths is 1 by 5. Okay, here is the probability 1 by 5. The probability of getting this EX grade in physics is 1 by 4, and the probability of getting EX grade in chemistry is 1 by 3. Okay, and the question is, what is the probability of getting at least one EX grade? So there are three subjects in a college, right? Each subject, so and there is this one grade, EX grade, and the probability of getting EX grade in each of the individual subjects is given by these numbers. The question that is asked is what is the probability that the a student gets at least one EX grade? Okay, so if let's define some event. So if A is the event that EX grade, let me just write EX in maths, okay. B is the event that EX in physics, and C is the event that you get EX in chemistry. This event of getting at least one EX grade, that will correspond to the set A union B union C, right? So let me know if it is not clear. So let's say that there are these three events A, B, and C, right? A, B, and C. So anywhere in this set, you will get at least one EX grade, right? If you are in the intersection of all these three events, then you are getting EX in three of them. If you are in at least one of them, you are getting one EX grade. If you are in the intersection of two events but not the third, then you are getting two EX grades. So this set, like remaining in this set, will ensure that you get at least one EX grade, right? Let me know if that is not clear. Basically, what I am trying to say is probability of getting at least one EX grade corresponds to probability of getting one EX grade. Uh, Sorry, probability of one EX grade union probability of two EX grades union probability of getting three EX grades, right? And that union, uh, So one EX grade is so I hope you can see that this set A union B union C is same as this thing, right? So the basically the question, and what are we given is, so okay, and these numbers are given to us, right? These numbers. So what is given to us is probability of A is equal to what? 1 by 5. Probability of B is equal to 1 by 4, and probability of C is given to be 1 by 3. Now the question is that is asked, what is probability of A union B union C, right? So let us write it down. Probability of A union B union C. We have to find this thing, this probability of this event, right? So what can we write it as? And the other thing that is to be seen is that A, B, and C are independent. Okay, so getting an EX grade in math is independent of getting EX grade in physics or chemistry, and that thing. So independence holds. So what is the probability of, so given this information, right? We have to find the probability of this event. So here is how you go about it. So whenever there is any kind of independence, you need to somehow manipulate this event A union B union C so that you can come to intersections, because you know that for independent events, since A, B, C are independent events, probability of A intersection B will be equal to probability of A into probability of B, right? So these nice properties hold, but only when there is an intersection operation. Here right now you have a union operation between A, B, and C. So 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 one thing that should come to your mind is, can we use some sort of De Morgan's law so that there is a complement that comes here. So here is how you go about it. So probability of this event A union B union C is equal to probability 1 minus probability of A union B union C complement, right? So probability of A, so probability of any event E is equal to 1 minus probability of E complement, right? Because probability of E plus probability of E complement is equal to 1, right? So I can write it like this. Now I have a complement here, and I can use De Morgan's law to make this as probability of A complement intersection B complement intersection C complement. Okay. Now one rule that I will be using is, if A is independent of B is independent of C, this implies that A complement is also independent of B complement is also independent of C complement. This is like, you can think that, if two events A and B are independent, so A is not dependent on B, then not happening of A is independent of not happening of B. This is one result that comes in handy. So not just that, this also implies that A is independent of B complement is independent of C, and like all permutations of it. Okay. So so this is how you can write. And then if A complement B complement and C complement are independent of each other, then you can write this as 1 minus probability of A complement times probability of B complement times probability of C complement. Here I have used simple independence. Now, what is the probability of A complement? I know the probability of A is 1 by 5. So the probability of A complement will be 1 minus 1 by 5, right? Similarly for B and C. So that will be 1 minus 1 minus 1 by 5 times 1 minus 1 by 4 times 1 minus 1 by 3. Okay. And what will this be? 1 minus, this will be 4 by 5 times 3 by 4 times 2 by 3. See if things get cancelled. 4 gets 4. So this becomes 1 minus 2 by 5. So this will be 3 by 5, which will be equal to 0.6, right? And yeah, so this is the answer. So yeah, any questions? So feel free to just ask questions in middle. if things are not clear. Okay, so no questions. So we'll move forward. Okay, so let us see the second question. Here is the second question. So the second question is basically saying that okay, there are, let's say there are three transmitters. So one, two, three, T1, T2, T3. There are these three transmitters, and there are three receivers R1, R2, and R3. Okay, so each transmitter transmits a digit. Okay, so T1 basically transmits the digit 1, T2 transmits the digit 3, and T3 transmits the digit 3. Okay, and R1 basically receives the digit 1, R2 basically receives the digit 3, R3 receives the digit 3. Sorry, R2 receives 2 and R3 receives 3. So there is this is some sort of communication channel R1, R2, R3, R1, R2, R3. Okay, so let me write it down. So Ti is basically the event that digit I is transmitted. Okay, and similarly Ri is the event that digit I is received. So there is one transmitter, there is one receiver. Transmitter can transmit three digits T1, 2, 3, and the each of these events is denoted by Ti, and the receiver can receive one of these three digits, and that event is denoted by Ri. Okay, now we are given some probabilities. So let's say the probability, it is given to us that probability of R1 given T1 is equal to 1 minus alpha. Probability of R2 given T1 is equal to alpha by 2, and probability of R3 given T1 is given by alpha by 2. So let's say the transmitter transmits the digit 1, okay, and after transmitting the channel through which this digit is getting transmitted is, let's say, has some sort of noise, and because of which the receiver might not be completely errorless. So there can be some errors because of which it is possible that you transmitted digit 1 and the receiver received some digit which is not 1. So what is the probability of that event? Okay, so those events are given to us. Those probabilities are given to us. So probability that R1 is received given T1 is 1 by alpha, 1 minus alpha. So this is like there is no error here, right? Because you sent the digit 1 and the receiver receives the digit 1, so there is no alpha, so this probability is 1 minus alpha. However, if there is an error and the receiver receives a digit R2, sorry, the receiver receives the digit 2, given that you transmitted the digit 1 is alpha by 2, and similarly the probability of R3 given T1 is given to be alpha by 2. Similarly, there are other probabilities that is given to us. Let's say probability of uh, R1 given T2. Now the digit 2 is transmitted, however you receive the digit 1. That probability is given by beta by 2. Probability of R2 given T2, this is the no error case, that is given by 1 minus beta, and probability of R3 given T2 is given by beta by 2. Right? Similarly, for T3 you are again given these numbers, which is gamma by 2. Probability of R2 given T3 is 1 minus gamma. Probability of R3 given T3 is given, sorry, I think this is also gamma by 2. sorry, this is 1 minus gamma. Right? So these are the three. So basically, you have this kind of a matrix, right, where the rows denote uh, which transmitter, which digit was transmitted, and the columns. So this row basically denotes that T1 is transmitted, T2 is transmitted, T3 is transmitted, and the columns denote which digit is received. So this here 1 is received, here 2 is received, here 3 is received, right? So this is the kind of channel, like this entirely defines basically the channel that you are working with, and it is provided to us that uh, alpha, beta, and gamma are between 0 and 1, so they are proper probabilities. Now there are some more things that is given to us. We are told that 3 is transmitted 3 the digit 3 is transmitted twice as often as 1. Okay, so the probability that a digit that the digit 3 is transmitted is twice the probability that the digit 1 is transmitted. Okay, similarly we are also given that 2 is transmitted thrice as often as 1. Okay, so what do these statements translate to in terms of probabilities? It's basically said that probability of T3 is equal to twice the probability of T1, and probability of T2 is thrice the probability of T1, right? This is given to us. So from the question that the the question that is asked to us is that, say that if 1 is received, okay, so at the receiver you see that 1 is received, right? Then what is the probability that 1 was transmitted? Let me know if the question is clear, because the question was a bit long. If the question is clear, then we will move forward. So this is the entire setup. You have been given some characteristics of this channel by these probabilities. You are also given some prior information that some 3 is transmitted twice as often, 2 is transmitted thrice as often as 1. The question that is asked to you is that you are at the receiver end and you see that you have received a 1, the digit 1. The question is, what is the probability that 1 was transmitted? Because it need not be the case that 1 was transmitted, right? There is a non-zero probability that T2 was 2 was transmitted and you received 1, or 3 was transmitted and you received 1. There is a non-zero probability of that. So if there is no question, then we will move towards the solution. First of all, we'll make use of these information, right? These things, the prior informations. We know that either one, so the so basically we know something like this: probability of T1 plus probability of T2 plus probability of T3 is equal to 1, right? Because either one is transmitted, or 2 is transmitted, or 3 is transmitted. It is not, there is no other possible transmission that is possible, right? There is no other digit that is transmitted. There is no other possibility. So if that is the case, then the sum of these probabilities should be equal to 1. Now we know that, let us write all of these probabilities in terms of P of T1, right? So we are given this is P of T1 plus probability of T2 is given to be 3 times probability of T1. So this will be 3 times P of T1, and probability of T3 is given to be twice. the probability of T1. This is P of T1. This is equal to 1. This implies, so 325 plus 1 6 times P of T1 is equal to 1. This implies that probability of T1 is equal to 1 by 6. So what we know is probability of T1 is 1 by 6. Probability of T2 similarly, we know it is thrice. So 3 by 6, that is equal to 1 by 2. Probability of T3 similarly is twice this thing, so 1 by 3. So this is the thing that we could extract from this information. Now, what is the question that is asked? One, what is the probability that one was transmitted given that one was received? One is received. So that probability basically is probability of T1 given R1, right? Probability that you had transmitted, the transmission was of digit 1 given that you received digit 1, right? So you can now apply your usual Bayes rule, right? So what does the Bayes rule say? Probability of T1 given R1 is equal to probability of T1 comma R1 by probability of R1, right? Now you can split the above thing as probability of R1 given T1 into probability of T1, right? Joint is the product of likelihood times the prior divided by probability of R1 can again be written as what? Uh, so this can be written as probability of R1 given, sorry, R1 comma Ti. I goes from 1 to 3, right? So it's like we are marginalizing all possible conditions when we can receive R1. This would simply become P of R1 given T1. So I'm trying to write it in terms of the probabilities that we know, right? And this joint can again be written as summation I equal to 1 to 3 probability of R1 given Ti times probability of Ti, right? So now we know all of these probabilities, right? Because R1 given T1 and R2 given T2 we know from this joint, from this entire table, and the priors we have already calculated here, right? So what is probability of R1 given T1? R1 given T1 was given to us by 1 minus alpha. So this is 1 minus alpha. And what is probability of T1? So the T1 is 1 by 6 upon, there is a sum here in the denominator, that one term is this above thing only, 1 by 6 plus what is probability of R2 given R1 given T2, R1 given T2, R1 given T2 is beta by 2, right? So this is beta by 2 times probability of T2, that is 1 by 2, plus gamma by 2. Probability of R1 given T3 was given by gamma by 2, and probability of T3 is 1 by 3, right? So this is 1 by 3. What does this become? uh, so let me make the denominator common. So this is 1 minus alpha by 6 upon 1 minus alpha plus, so this will become 1 minus alpha by 6 plus this is beta by 4, right? Plus gamma by 6. So maybe just multiply these 2 by 2, okay, and multiply this by 3. This will become 1 minus alpha by 6 upon 2 into 1 minus alpha plus 3 beta plus 2 gamma upon 12. 6 2s are 12. So this will become 2 into 1 minus alpha upon 2 into 1 minus alpha plus 3 beta plus 2 gamma, right? So this is the probability, right? So this is the answer. Let me know if something is not clear. I'll just drink some water. Let me know if something is not clear, Something was, it seemed too fast or something like that. Just let me know. Okay, seems that everything was clear. So, okay, fine. Hmm. Yeah, yeah. So there is a single transmitter. These are the events. So it's like there is a single transmitter. It can transmit three things. Okay. Yeah. Any other question? Okay. So maybe so okay okay, related to this the same question, there can be another question that could be asked. Okay, let me make that the third question. So if someone asks what is the probability of error, so okay, so like you can see, right, that there are three possible transmissions. However, at the receiving end, it is not necessary that you receive the same digit that was transferred. So there can be errors. So what is the probability that there is an error? So let us try to find that thing. What is P of E? So so probability of error, can again we can use the marginalization argument. It is equal to summation I equal to 1 to 3 P of E comma Ti, right? So since Ti, T1, T2, T3 are like partitions of the sample space, you can always condition the main event on that. Uh, so, so, so if when I'm writing comma, it basically means I equal to 1 to 3 P of E intersection Ti, right? So basically what this says is that I am using the simple marginalization argument here, and now why I'm doing this, because now it will become simpler. What I will next do is I will look at individual transmitters, so individual events T1, T2, T3, and see if T1 happened, basically what is the probability of error. If T2 happened, what is the probability of error? T3 happened, what is the probability of error? That is simpler as compared to just directly analyzing this probability of error, right? So this thing can be written as probability of I equal to 1 to 3 probability of E given Ti times probability of Ti, right? Just writing the joint as the product of likelihood and prior, and this is equal to, so okay, what is P of, so this I will just write it down individually. T1 plus probability of E given T2 times probability of T2 plus probability of E given T3 times probability of T3, right? These things are there. Oh, recording is happening, right? Okay. So what are these individual? So okay, so if T1 has occurred, right? So T1 is the event that 1 is transferred. What are the cases when you will declare an error? So if T1 happened and you received R, so and you received the digit 1, so R1 happened, there is no error. So here there is no error, right? Everything is fine. However, if you transmitted 1 and received 2, there is an error. If you transmitted 1 and received 3, then also there is an error. So alpha by 2 plus alpha by 2 is the probability of error given that the digit 1 was transmitted, right? I hope This is clear. If not, let me know. I will explain it. So what I'm trying to say that this thing is equal to uh, alpha. So this is alpha by 2 plus alpha by 2 times priority of T1. T1 priority of T1 we had calculated, which is 1 by 6. Similarly, probability of E given T2 will be beta by 2 plus beta by 2 times priority of T2, I think, was half, plus mm, E given T3 should be gamma by 2 plus gamma by 2 times 1 by 3, right? 1 by 3. If it is not clear, let me know. Now this is nothing but alpha by 6 plus beta by 2 plus gamma by 3. This will become what? Alpha plus 3 beta plus 2 gamma by 6. This is the probability of error. If something is not clear, feel free to just ask question. Okay, only two people out there. No worries. Okay, so let's move to the next question. Is the fourth question. Uh, so we are given that, let's say f is a function from. So this is a question on CDF, properties of CDF, R to R. Okay. So the question is, you have been given a bunch of options. So the first option is f of x, and you are basically asked which of these is not a probability dense. Which of these is not a CDF basically. B is f of x equal to 0, 1, x greater than equal to 0. C option is f of x equal to 1 by pi tan inverse x plus pi by 2 for minus infinity x less than infinity, and D option is f of x equal to 0 when x is less than equal to 0 and 1 minus e raised to minus 2x greater than 0. So which of these is not a CDF? So the way I like to do these questions is just first plot these individually. So let's say, how does the plot of each of these look like? So this function, the first option, is basically 0 when x is less than 0. Okay, so this is 0, so it is 0 till here, and at 0 it basically says that it is a linear function, right? The graph looks like this. And for this option, the B option, it's 0 till here, then there's a jump towards 1, and it stays till 1 for after that. And okay, the last option is, it is 0 till here, okay, and after that it's 1 minus e raised to minus 2x. So if you see, if x goes to infinity, this e raised to minus 2x will become e raised to minus infinity, which will become 0. So hence at infinity this function is 1. So it's like the graph will look something like it's an asymptotic graph, something like this, right? Y equal to 1 is an asymptote here. And how does this function look like? This the C option. I'll just try to draw it here. So this is 1. Okay, use this color only. So this is 1, this is 0. This function tan inverse x looks like something like this, right? Something like this. However, it is shifted by pi by 2, so this thing is minus pi. So, I mean, just maybe you can do it this as an exercise or something, but the graph of this thing looks like something like this. Okay, let me draw it properly. This is how this graph will look. C option will look. So, given these three options, which one is which one? First of all, which one are the CDFs? So the property of CDF is that it has left hand limits. It is right continuous. It has left hand limits. When x goes to minus infinity, the function should be 0, and when x goes to plus infinity, the function should be 1. So by that logic, I hope you will see that the B option, it satisfies all these three properties. It is discontinuous at 0, but it has that left hand limit there, and it is right continuous elsewhere. So B is correct, because and at as x goes to minus infinity it is 0, as x goes to plus infinity it is 1. Same goes with C option, because this is not a discontinuous function, so it is a perfectly continuous function, no issues there. At minus infinity it is 0, at plus infinity it is 1, so this is also perfectly good CDF. Same thing goes with this third last option, because it is discontinuous at uh, 0. However, it has left hand limits, and it is right continuous. It is so the function is continuous, but it is not differentiable at 0. But differentiability is not a required thing for CDF. So this is also a correct option. However, you can see that the first option here, this function is left is right continuous and has left limits, that is fine, but the issue comes because at x equal to plus infinity the function goes to plus infinity, right? And hence this is the option that is incorrect. So this is the first option is not a CDF. I hope this is clear. If not, let me know. It's a simple question. Okay. uh, okay, moving forward, fifth question. uh, so so this is a simple question. So an exam has there are 5 papers in an exams, okay, and the probability that uh, a person, a given student solves the problem. So the let's say the name of that student is Alex. Solve probability that Alex solves a problem correctly is equal to 3 by 5. Okay. The question that is asked is, what is the probability that it Alex Alex solves at least one problem correctly. So maybe I should this should not be papers, 5 problems. Okay, so so basically the probability that this guy Alex solves a problem correctly is 3 by 5, and he has to solve 5 such problems. What is the probability that he solves at least one of the problems correctly, right? So let A, here is the solution. A be the event that he solves one at least one problem correctly. right? Then what will be A complement? A complement will be he solves no problem, right? So we have to find the probability of A. This can be written as 1 minus probability of A complement, right? And what is the probability of A complement? If he has to solve no problem correctly, then he has to basically incorrectly solve all the problems, right? All the 5 problems. What is the probability that he solves a problem incorrectly? If the probability of solving it correctly is 3 by 5, then problem of solving it incorrectly is 1 minus 3 by 5, right? And he has to do it for 5 problems, and yeah, you have to raise it to 5, right? So this will become 1 minus 3 by 5. This will be 2 by 5 raised to 5. 1 minus what is 2 raised to 5 is 32, and 5 raised to 5 is 5 square is 25. 25 square is 625. 625 times 5. You can solve this. I think you will need a calculator. It's not straightforward. Yeah, so like just do it. Yeah, use calculator or something. Just solve this. Get this number. Right. So, this was an easy question, very simple question. Here is another question. So yeah, so if there is any question, just feel free to unmute yourself and ask it. Okay. Okay, so there's no question, then let's go to this next question. Let's say that A and B are two events. These are independent of each other. Okay. Uh, there are a bunch of statements that are given to us, and we are asked which of these is not correct. Okay. So let's see all the options. So the first option that is given is A and B complement, are these two independent? Second option is A complement independent of B. Third option is are A complement is A complement independent of B complement? Like, is this correct? Or the D option is A is independent of A complement. Okay, so so whenever you have to check independence, there is only one thing that should come to your mind, which is if A and B are independent, then probability of A intersection B is equal to probability of A times probability of B. So if you want to let's say check if this is correct, you just need to check if probability of A intersection B complement is this equal to probability of A times probability of B complement. Is this correct or not? If this is correct, then the statement is true. Okay. So just to make sure, we will need this Venn diagram. So I will just make it anyway. Okay, so this is A, this is B. Okay. Okay. So what is probability of A intersection B complement? This thing can be written as uh, how can we so we only know this thing, right? So we have to basically break everything down in terms of A intersection B, so that it becomes easier for us to you know uh, basically exploit this independence of A and B. So let's try to do that. So A intersection B complement, right? So if this is your sample space, then A intersection B complement. So B complement is what? B complement, let me use some other color. B complement is everything that is here, right? Outside B. Okay. What is the probability of A intersection B complement? I hope you will agree that this portion is what is the set that will be A intersection B complement, right? So this thing that I have drawn, maybe let me use some this thing. So this set can be written also as probability of this entire thing A minus probability of this thing which is intersection. If you remove this thing from this entire big thing, you will get what is desired, this thing, right? So you can write this as probability of A, this entire whole thing, minus probability of A intersection B. Let me know if this is not clear. So this is the thing that this is the set that we are required to find probability of. I'm saying that this thing is equal to the this entire thing minus this thing. Okay, and now you can use the independence because you know this probability is now product of individual probability. So this is P of A minus P of A into P of B. This is equal to P of A will become common 1 minus P of B. Now 1 minus P of B is P of B complement, right? P of A times P of B complement. So this is what was desired, right? Here. So this shows that A and B complement are actually independent. So this is a right statement. This is a correct statement. Similarly, what about A complement intersection B? The second thing. So this was A, right? Let's see what is B. Probability of A complement intersection B. Now, actually, you can just use the same argument because A and B are not, they are. So it's like you have replaced B by A and A by B, right? It is the same thing actually. Uh, because so is that clear that if I replace here A by so if I replace A here by B and B by A, this is the exactly same thing. Is that clear to you? I don't know because A and B are yeah. So using the same thing, you can just write this as also as A complement times P of B, and like this statement is also true because there is nothing special about A and B. They are just interchangeable, right? Now, can we write something same similar about A complement intersection B complement? What will be the probability of A complement intersection B complement? Let us see. Can we write something? Hmm. So I hope from you can see that this is A union B whole complement from De Morgan's law, right? And this thing is equal to 1 minus probability of A union B. Is that also fine? Yeah, because yeah, right. So now what I can do is if I have to write the probability of A union B, I can use inclusion exclusion, something like probability of A plus probability of B minus probability of A intersection B. Hope this is also clear to you because this is just inclusion exclusion. And then now I know that this thing is equal to probability of A into probability of B. 1 minus P of A times P of minus P of B times minus probability of A times probability of B. Now it's simple. Oh yeah, this is probability. Yeah, yeah, sorry. Yeah, you are right. This will be plus. Now what I will do is I will just take this thing, and I will take P of B common from here. So this is 1 into 1 minus P of A minus P of B will come out, and 1 minus P of A, right? Now 1 minus P of A is common in both these terms, so this will come out common into, so here 1 and minus PB, 1 minus P of B, this will come out. Now 1 minus P of A is equal to P of A complement, and this is P of B complement, and hence this is exactly equal to the product of these individual things, right? So this is also correct. So the third statement is also correct. What about the fourth statement? So D, what is probability of A intersection A complement? Well, probability of A intersection A complement is equal, so well, let's say this is your set A. A complement is everything that is outside this thing, right? So there is nothing in intersection. This is actually probability of phi, null set, and that is equal to 0. However, what is the probability of A into probability of A complement? This is equal to probability of A. Probability of A complement is 1 minus probability of A, right? Which is equal to, probability of A minus probability of A square, right? This need not be 0, by the way, because if probability of A is greater than 0, if probability of A is equal to 0, then fine. However, then it is okay. However, if probability of A is not equal to 0, if it is greater than 0, then this thing is actually greater than 0, right? And if that is the case, these things are not equal. So this statement is wrong. So which is the this is a wrong statement. Yeah. Yeah, okay, yeah. So yeah, I mean, so this thing is equal to 0 only if probability of A is equal to 0 or probability of A is equal to 1. Sorry, yeah, that is also a perfectly valid case. Yeah, you are right. So yeah, so this is actually a nice result to remember actually, that if two events are independent, then their complements, everything is independent of each other. Okay, let me just check if the recording is going fine. Yeah, hopefully everything is fine. Okay. Uh, Let us look at one more question. I don't know how many questions I will be able to cover, but actually I am feeling a little bit under the weather today, so I might end things a little bit early. Okay. Okay, here's another question. Let me just drink some water just to stay hydrated. Okay. So let us say that there is a disease, okay, and there is some test for that disease. So for example, we recently had COVID, right? And there were several tests that were proposed. So similar to that, there is some disease and there is some test for that. Okay. So it is given to us that uh, there is a diagnostic test which is correct 95% of the time, right? So with probability 0.95, the test gives correct result. Okay, and with 5% it gives wrong results, right? Uh, so what does this mean? If a person has the disease, then it will say that the the person has a disease with 95% probability, and if the person doesn't have a disease, the it with probability 0.95, it will say that the person doesn't have a disease. Okay, so the diagnostic test is not always about saying if the person has a disease, it is also about saying the person doesn't have a disease. Okay, and it is given to us that 0.5% of the population has this disease. Okay, has this disease. So so a person is chosen at random. Okay, so from the population, a person is chosen at random, and the test indicates that the person has the disease. Okay, what and so basically the question that is asked is that what is the probability of disease given that test indicates indicates test is positive. Test is positive. So that so you chose a person at random from the population and you tested it and it came out to be positive. What is the probability that the person actually has the disease? So so let E denote the event a person has a disease. Okay, and F denote the event that the test is positive. The question that we are asked is, and we are given that probability of E, this thing, probability of E, that person having a disease, that is given to us, right? Because it is just 0.5%. So this is 0.5 out of by 100. The question that we are asked is, uh, what is the probability of E given F, right? So it is given that test is positive. What is the probability that person actually has a disease? So now again you will use the usual Bayes rule, which is probability of E comma F by probability of F, right? So now this thing can be written as probability of F given E times probability of E upon. So now probability of F can be partitioned again, right? So this can be written as probability of F given E times probability of E plus probability of F given E complement into probability of E complement. This is the usual Bayes rule. If there is any doubt here, you can just tell me. So, if a person has the disease, what is the probability that the test is positive? That is given to us, right? That is 95%. So that is 0.95 into probability of E. That is this number, right? That we just saw. It is given to us. That is 0.005, right? Divided by 0.95 times 0.005 first term plus what is the probability that the person doesn't have a disease and the test indicates that the person has a disease. That will be 1 minus 0.95, right? So that will be 0.05 times what is the probability of E complement, that is 1 minus this thing, so that will be how much, 0.995, right? Now I mean, you will have to do this on a calculator too because the numbers aren't looking very nice here. Just do this on calculator. Whatever the number is, that is the answer, right? So again, a simple question, not a very tough one. If there is any question, you can tell me, or can move on to the next question. Okay, okay, okay. So we'll move on to the next question. So here is another question. Again, the use of basically conditional probability and everything. So there are three events E, F, and G. Okay, it is so we are given some probabilities. We are given probability of E is given to be 0.3. Probability of F given E is given to be 0.2. Okay, and probability of G given E is given to be 0.1. And what else? We are also given that probability of F intersection G given E is equal to 0.05. And we are asked, given all this information, we are asked what is the probability of E minus F union G. Okay, okay. So these are the things that are given to us. So basically, you have to write this probability in terms of everything that is given to you here, right? That is the basic idea behind this thing. Uh, okay. So let us do this thing. So probability of E into probability of F given E will give you the probability of E intersection F, right? Which is what? Which is probability of E was given to you 0.3 times 0.2, right? 0.3 into 0.2, which is equal to 0.0606. Okay, okay. Let us keep that. Similarly, probability of E into probability of G given E will give you probability of E intersection G, right? What will that be? 0.3 times G given A is 0.1, so 0.1 which is equal to 0.03. That is also right. Okay. Now another thing is probability of E into probability of F intersection G given E. This will give you probability of E intersection F intersection G. Is this fine? This will be 0.3 into 0.05, which is equal to what? 0.015. So basically I am trying to get the intersection probability of all the intersections here. So so let us draw the Venn diagram, right? To see this event, the best way is to visualize it. So let's say there are these three events E, there is one more event, say F, and there is this one more event which is G. So E, F, and G. So and the event that is in question is E minus F union G. So what is F union G? F union G is this set. This thing, this entire thing, that is your thing, which is F union G, right? Now the question is that if you remove whatever it intersects with E, so I hope you will agree that this set, so this is F union G. You have to basically find E minus everything, E minus all this thing. So E minus all this thing, what will that be? So you just remove everything, right? You just remove this part and kind of see this thing. Sorry. So whatever this set is, you're being asked the probability of that set. So so what I hope you can see that there are two three things that you will have to remove from this thing, right? So one is this thing. So okay, so if you remove this probability, okay, and there is this another thing that is here one, and then there is one more thing that is here. So from E, if you remove these things, then you will get the probability of the shaded region that is there in red. Now let me call each of these something, so that let's call this 1, let's call this region as 2, let's call this region as 3. So what is 1? 1 is actually uh, what is it? Is it easy to see? Mm, so actually if you see, okay, right, if you remove that part, yeah, so okay, so actually 1 can be seen as you take E intersection F, okay, and but E intersection F is this entire thing, and then you add this thing, that union. So you take E intersection F and you subtract E intersection F intersection G. That is the region 1. Similarly, this 2 is simply E intersection F intersection G, right? And 3 is similarly G. So G, the third region is E intersection with G minus E intersection F intersection G. Okay. So if you add these three sets, you will get this black colored region, the set that corresponds to this black colored region. If you add it, what will that become? It becomes E intersection G plus E intersection F. Now it is this set is added one time, subtracted one time, and subtracted again another time. So this will just be subtracted one time. E intersection F intersection G. So the probability of this thing, let me write it down. Probability of E minus F intersection G. This is equal to probability of E minus this thing, right? Probability of E intersection G minus probability of E intersection F plus probability of E intersection F intersection G. Now what is probability of E? Probability of E is given to us, that is 0.3. E intersection G, what is the probability of that thing? That is given to us 0.03. 0.03 minus probability E intersection F is given to be, we calculated that it is 0.06, and probability of E intersection F intersection G, we calculate that as 0.015. So this becomes what? 0.3 minus 0.09 plus 0.015. So this becomes 0.315 minus 0.09, which is equal to what? This will become 315 minus 9, right? Uh, this will become 0.225, right? Yeah. So yeah, so this was like a little bit tough, not very tough, but kind of a tricky set theory question. Basically, you'll have to identify what is the set exactly, so that you can, manipulate things and come up with the correct answer. So I think this was the last question for today. Any questions here? Okay. So yeah, these are the questions that I had planned for today. So I don't know, was there any question which was common to week two, this year's week two question? I don't know. Okay, okay. It is possible that some questions would be common because they keep repeating and I don't have a tab on what they decide. So yeah, it's okay. There's no issue. So, but the rest of the problems, so these problems are similar to the problems that are given to you in your assignment, so that it is sort of you know, so it becomes sort of easy for you to solve those questions by attending these TA sessions. So, if there is no more question, then I will stop sharing, stop presenting. Yeah. So that will be the end of this session. Thanks for joining. Yeah. I think we'll end the meeting now. Okay. Thank you and have a nice day. Bye.